So like I was saying, I apologize. Like I was saying, this table looks a little bit more complicated than we're used to seeing, but we're going to be doing all of our work in this table so we can get our results. So the directions you're going to see are to evaluate the function y equals x plus 3 for the following x values. And you'll see we have 5 x values here on the left side of our table. We've got our function here in the middle of our table. Right here is where we are going to put the y values that we solve for, and then we're going to put our x and our y together to find a point on that function. All right? It's exactly like we just did in the warm-up, except instead of using b equals y minus mx, we're just going to use y equals mx plus b, because what we're solving for here is y. And since y is already isolated, we don't have to do anything to our equation like we did when we were playing bingo. Right? So all we're going to do is we're going to take this negative 2, and right here in this space, actually, let me write down what each thing is first. So this right here, these are our x values. This right here is our function. Then we've got our y values. And we got all of our solutions, which are just points on the line. Now, when we were playing math, though, we had to substitute 3 numbers in, right? We had to put the b into the equation, we had to plug the x into the equation, and we had to plug the y into the equation. Luckily for us here, all we have to do is plug in the x value that we're given. It's very simple. Here's what we're going to do. Y is equal to, we're going to take out x, and we're going to replace it with whatever our x value is right there. I'm going to get rid of the directions for a second so we can zoom in. There we go. Can everyone see that okay? Okay. There you go. What? So this is our setup, right? Looks very familiar. Whenever we're going to replace a variable with a number, we first put those open parentheses there, and then we're going to plug in our negative 2. Just like that. Give me a thumbs up if you see where I got this negative 2 from. Okay, good. We see. It's right here, right? And these x values, they're all going to be given to you. So you're not going to have to do any guessing or anything like that. But in reality, we could plug any x value into this function and get out a y value. Even if we plugged in 1 million, right? If our x value is 1 million, our y value is going to be 1,000,003 because we're just adding 3. But for right here, when our x value is negative 2, what is our y value going to be? Well, what's negative 2 plus 3? 1, right? So our y value is 1. Not too bad, right? And then we write our ordered pair of negative 2, comma, 1. Yes? Is it going to get harder? Good question. I don't know. Maybe. I think. Difficulty is, what is it called? Objective? Subjective? I don't know the difference. One of the two. It's different for everyone. Now we're going to go on to the next x value. Y is equal to blank plus 3. What are we going to plug into that blank? Negative 1. That's right. That's our next x value on the table. Now what y value is this function now going to spit out here? Negative 1 plus 3 gives us positive 2. And our ordered pair is negative 1 was our x value. Positive 2 was the y value we just found. Great question. We're not going to graph them today. We'll build up to that, but I don't want to throw too much at you guys at once. Right now, we're just figuring out how to evaluate these functions. In evaluate, this term, you're going to see, oh, you can't see it, but the term evaluate, you're going to hear that a lot in math. It's almost synonymous with solve or find the answer to. All these terms mean the same thing, right? So whenever you see a direction telling you to evaluate, you know that your answer is going to be a number of some kind, right? We're plugging our x value into this function. We're evaluating what's going to come out, and then we get our result. Okay? Let's move on to the third x value. Y is equal to open parentheses plus 3. What are we going to put in these parentheses here? 0, right? What's 0 plus 3 going to give us? 3. Now, some of you may be thinking back to our previous lesson about, essentially about this exact thing. And you may notice, hey, look at my y values. We got 1, we got 2, we got 3. What do we think our next y value is going to be? 4, right? Let's make sure that's correct. Y is equal to blank plus 3. Plug in a 1. And 1 plus 3 does, in fact, give us 4. And finally, last one, we plug the 2 in. We get 2 plus 3, and that gives us 5, right? Show of thumbs, how are we feeling about filling out this table as of right now? Not too bad, hopefully. Maybe we could do another math though with this, maybe. We'll see. So we are almost done. We got to do a little bit of what we talked about yesterday, right? We just evaluated this function. Now what we're going to do is we're going to describe this function. So, is this function proportional? That's our first question. Is this function proportional? What do you guys think? Give me a thumbs up if you think it is proportional. Give me a thumbs down if you think it is not proportional. Oh no. Why is everyone's thumb up? Okay. Keep in mind, folks, proportional relationships don't have a value for b, right? There's no b value there. Maybe we're confusing it with linear. Potentially. That's okay.
I saw 0.
So, this is non-proportional. If you ever forget, we have nice clear notes that we took yesterday on exactly what a proportional and non-proportional relationship look like. But for here, it's non-proportional because b is equal to 3. B slash c just means because. It's a shorter way of writing it. So this function we know is non-proportional because we see, hey, look at this. 0, 3, that's our y-intercept. Right? And we can see even in our original function that we have a value for b that is not 0. Therefore, our whole function's non-proportional. However, is this function linear? Yes, it definitely is, right? How do we know that this function is linear? There's not just one answer to this. There could be multiple answers, but how do we know this function is linear? Because it's a straight line. I don't see any straight lines graphed here, so we can't say that. Hannah? One more time. No exponents. Beautiful. That's what we wrote down in our notes yesterday. Let me pull it out real quick, and we'll take another look. Chapter, here it is. Nope. Here it is. So we were talking about linear versus nonlinear, right? Linear functions have no exponents in our equation. Now, if we had a graph, we would be able to see is it a straight line or not? But if we don't have a graph, we have to look for exponents in our equation. If there are none, we know that it's linear, right? Is this function linear? Yes, linear, because no exponents in our equation. Is there another way that we know that this is a linear function by chance? Let's take a look at the change in x versus the change in y. Does that look like a constant change in x and a constant change in y as we move down? Here we're just adding 1 each time. And for the y, we're just adding 1 each time. Those constant changes tell us this is linear. So even if you forget about the whole exponent thing, if we're able to find a pattern like this, we know that it's linear right away. Okay? But luckily, we'll always get the function, so as long as you can remember, hey, if there's exponents, it's nonlinear, then you'll be good. Most of the lines we're going to talk about are linear, but our third one here in the notes, our last one, is going to not be linear. So we'll talk about that when we get to it. I'm going to bring this down, and let's get our second example going. We're setting up another table, just like this one. You won't have to draw the tables on the worksheet, don't worry. Let's do y equals negative 2x plus 1.
Never heard that. No, they don't. I've never heard a giraffe make a noise.
We'll call this one example B. And for our x values, let's go ahead and do, what do you want to do? Let's do
18.
Let's go negative 3, negative 2, negative 1, and 0. We'll only do 4 for this one. Make it a little easier. Negative 2x plus 1 is our function here for example B. Negative 2x plus 1. Yeah, that works. So once again, all we're going to do is we're going to take out our x. We're going to leave everything else around it. What's up? Yeah, go ahead. He's right there. So here's what our first little function setup looks like. And what number are we going to plug into these open parentheses here? Negative 3, that's right. That's our first x value. We're going to plug that in right here. And now we have to do a little bit more. We have to do one additional step. And that's multiplying, right? First, we have to multiply negative 2 times negative 3. And then we're going to go ahead and add 1. All right? So what is negative 2 times negative 3? 6. Perfect. Thank you, Brandon. Positive 6. Plus 1 gives us 7. So don't just multiply them and put that number as your y value. You've got to make sure you're adding your b as well. Whatever number's hanging off here, whether it's adding or subtracting, you've got to remember to keep that there. So this coordinate pair here is going to be negative 3, comma 7. Now if we had to, or if we were asked to graph, now we could take all these points that we're finding, graph them all, and just connect them up with a line, right? Second one, y is equal to negative Oh, did I mess up? I did. No, I didn't. Negative 2 times negative 2 now is our x value. What's negative 2 times negative 2? Positive 4 plus 1 gives us 5. There we go. Seems like we're starting to get it, right? Hopefully. I'm going to set up all my ordered pairs real quick. Keep in mind too, yes, Blake? Sure. Keep in mind too, if you need a little bit more extra space to work this part out, there's plenty of space on the worksheet for you to do so, okay? If you can't, or if you're having a little bit of trouble getting this whole equation solved out in your head, that's totally fine. You can work it out in the margins here. There's plenty of space on the worksheet for you to work it out. But all you're doing is multiplying them and then adding. So if you just take it in 2 steps, you should be able to do it in your head, as long as your multiplication facts are on point. Let's plug in a negative 1 down here. What's negative 2 times negative 1? Positive 2, thank you, Max. Plus 1 gives us 3, right? Now take a look at our y values. We got 7, 5, 3. What's next? 1, right? Let's confirm. Plug in a 0. Negative 2 times 0 gives us 0. Plus 1 gives us 1, right? So we're good on that. Now, I don't want you to always follow the pattern like that and then just stop doing the work. You do have to evaluate them all here as well. Your table's got to be fully filled out. Okay? Because if I didn't put all these x values in order, if I just said like 5, negative 2, 0, and 6, you wouldn't see that pattern when you're going through. So I do want you to go one by one by one and evaluate each x value with this function to get your y value. All right, our table is complete now. Is it proportional? What do you guys think? Thumbs up, it is proportional. Thumbs down, it is not proportional, or non-proportional as we call it. Good, okay, there's our thumbs down. This is non-proportional. Because, why? Azalea, why is this non-proportional?
Because our B isn't 0.
That's right. Our B value is equal to 1, right? And whenever our B value is not 0, it's immediately non-proportional. Is this function linear? What do you guys think? Thumbs up, yes, it is linear. Give me thumbs down, no, it is not linear. What do you guys think? Do you see any exponents in the equation? I don't see any exponents in negative 2x plus 1. So I'm going to say, yes, this is linear. There are no exponents. Questions about example B? Questions about example B at all? Okay. Now let's kick it up a notch. Uh-oh. You'll be fine. It's not that bad. We've been talking about a lot of no exponents, right? Let's take a look at one with some exponents in our function. Go ahead and make one last table here. Guys, let's focus, please. So our function here in example C is y equals x squared. Y equals x squared. So all we're going to do is we're going to take y equals, we're going to open up our parentheses, we're going to keep that exponent of 2 right up there on the top of our parentheses. And what number are we going to put in those parentheses, guys? We're going to put x, but what is our x value here? -2, right? Now, -2 squared. What does that mean? Are we adding 2 to -2?
No.
Are we multiplying -2 by 2?
No.
No, what are we actually doing when we see this, Noah?
Multiply -2 by itself twice.
That's right. We're multiplying -2 by itself. That's what this exponent means. It's not -2 times 2. It's -2 times -2. Right? Just a quick exponent review. Right, when we see -2 with an exponent of 2, we know that this is how many times we're multiplying -2 by itself. So we're doing it twice. We got one -2 here and another one here. When we multiply these together, what do we get? Positive 4. Let me ask you guys a question. Is there any negative number we could plug in right here and get a negative answer? Is there any negative number we could put right here with this exponent of 2 that's going to give us a negative answer? Brandon?
Positive, like
Well, if we have a positive 2 squared, right? That's a good point. We multiply positive 2 times positive 2, and what does that give us? Positive 4, right? Just like with the negatives. We got the same number. So is there any negative number that I can square and get a negative number? 1? -1 times -1 would be positive 1, right? Positive 1. What happens when we multiply a negative number by a negative number? We get a positive. Do we always get a positive? Yes, we always get a positive. So if we're squaring a negative number, our answer is always going to come out positive, because what we're doing by squaring it is multiplying a negative by a negative. Okay, that's something to keep in mind as you move through your math classes, all right? You're never going to get a negative result when you square a number. So if we have -2 squared, our y value, like we said, is going to be positive 4, right?
Yeah.
So our ordered pair is going to be -2, comma 4. Let's go to our next one. Y is equal to, open parentheses, squared. We plug in that -1, right? So -1 squared is just a fancy way of saying what's -1 times -1. And that gives us what? Positive 1, right? Positive 1. Now what about this next one? Y is equal to 0 squared. What is 0 squared going to be, Brandon? Or did you have a question? I'm sorry.
oh yeah, I was gonna go backwards, but it's gonna be 0.
That's right. Go ahead. It is going to be 0. 0 times 0 is just 0, right? So we've got this point 0, comma 0, just like that. Now let's talk about the positives. We plug in a positive 1 here. What's positive 1 squared going to give us? Noah? Positive 1, right? And then let's just do the last one. Y is equal to positive 2 squared, and that's going to give us a y value of positive 4, right? Now let's take a look. Do we have 5 different inputs here?
No.
Inputs are x values. Do we have 5 different inputs here? Yes, we do. Do we have 5 different outputs here? No, we don't. So remember, what makes something a function? Think back to Monday. What makes something a function? If you need to flip 2 pages back, you can. It's in your notes. You're all looking at your notebooks. What makes something a function? If we can't answer that, we're in trouble. Jordan?
I think the x can't.
One sec. Jordan's got the floor, folks.
The x can't repeat.
The x value can't repeat. Blake, do you want to read out what makes a function for everyone? Oh, okay, got you. Olamipo? Go for it. There we go. Set of data, or a relationship between data where each unique input has a unique output, right? Is that what you said it was? That sounded a little bit weird when I said it, but we can't have repeating x values. However, we can have repeating y values, okay? So if you see this and you go, wait a minute, I've got a 4 here and a 4 here, I kind of remember that means it's not a function at all, so this must not be a function. Only if we have repeating inputs or repeating x values is it not going to be a function. So this is still a function, but now let's describe this function. Let's ask this first. Is this function going to be linear?
No.
No, Brazon, why is this not going to be linear?
Because it has exponents.
That's right. There's exponents in our equation. Now here's the real question. What do we need? Actually, no, let me phrase that differently. Give me a thumbs up if you think this is going to be proportional. Give me a thumbs down if you think it's non-proportional. Thumbs up for proportional, down for non-proportional. Good, good, good. I see about a 50-50 split. This is going to be non-proportional, folks. Now, you may look at this and go, hey, wait a minute. No, it crosses through the origin. That makes it proportional, right? That's half of what makes it proportional. What's the other half, folks? It's got to be linear. Is it linear?
No.
No, so it's also non-proportional. Even though it goes through the origin, it also has to be a straight line. This is not a straight line. Okay? We'll see what this looks like graphed another day, not today. But it's what we talked about yesterday, a parabola, that U-shaped graph. Even though it goes through the origin, it's not a straight line. It's a curved line. So proportional, no. Even though it crosses through the origin, it is non-linear, which also makes it non-proportional. It's kind of like how a square is considered a rectangle, but a rectangle cannot be considered a square. They are the same thing. One of them is just a little bit more specific. Give me a thumbs up if you see why this is non-proportional here. Okay, I think we're all thumbs up at it. Okay. That's the end of our notes.